There we go. Okay, so, and we're recording. All right, welcome back. Get comfortable. Again, if you need to move, you need to lie on your stomach, you need to do something different, take care of you. And if there's anything you need, I trust you to let us know. Everybody have some good food in your belly? Yeah, good, good, good. And I have a warm drink to keep my throat lubricated. All righty, so when we left off on Tuesday, we were talking about Stitra and Sukha, sharp objects, the sharp object of the mind and the scalpel for examining anatomy. And those analogies and bringing things back to this historical perspective, the scientific perspective, the metaphysical perspective, and bringing that all together. The reason I have this conversation as we approach the material is to keep in mind that when you see a drawing of something anatomical, like a drawing of the heart, that's a representation of what the heart should look like or what the lungs should look like. When we look at a cadaver, not that everybody is comfortable looking at a cadaver, no one has to in this course if you don't want to. When you look at a cadaver, it's another person, it's not you. Every individual human is a little bit different. And this conversation is about keeping that in mind as we approach the study of anatomy and physiology, and knowing that we're studying systems and it's really difficult to tease apart and pull apart one system away from another. So even as we have conversations about how systems work, they're all completely interrelated. And I just wanted to repeat that message from Tuesday. We're going to continue that conversation about anatomy. So if you want to take notes, you can. Some of these things will be in your course pack, and some of them may be things that are from my experience or from other courses that I've taken from my notes. And go back to we were talking about Gil Hedley and Thomas Myers, if you remember that, about anatomy trains, and they are both really well known for studying the cadaver, studying how the fascial trains work in the body, and understanding how different cavities in the body are surrounded by different fascial layers. And there's the skin and the fatty tissue and the fascial layers. And they've done anatomy labs that you can actually see. So if you find yourself really interested in how the human body works, I say the anatomy labs that are run by Gil Hadley and Thomas Myers are pretty spectacular and very reasonably priced. If we had to set up a day for us to go to the anatomy lab at the University of Toronto, it's a really expensive expedition. I've checked it out before, and we would probably be looking at somewhere between $1,000 and $1,500 to go in and have someone take us through a cadaver. So when for 30 or 40 bucks, you can get to see an expert dissecting the human body, see how it all works. If it's interesting to you, it's a really exceptional and worthwhile thing. I think it's a worthwhile thing to do if you're open to it. And if you're not, don't stress over it. Don't think you should just because somebody else does, right? And when they run a 6-day cadaver dissection lab to study anatomy, and they dissect the traditional way by cutting through the front, what they call the deep front line. And this story that's told by running your scalpel this way and seeing the connection between all of the structures, it's usually given individual names to all of the different parts of the body. And that's what we study in our anatomy notes and in the different videos that we're looking at. It's the way most anatomists understand the body. The only way to get apart is to take your scalpel and go, okay, so this begins here and ends here, and has a name because it's a part of the human body. And another way to look at the body is to say, well, what if we're not interested in the parts? What if we're interested in lines of connection, the continuities, right? How would we use our sharp instrument to tell that story? So actually, Thomas Myers, and I think Gil Hedley might have done this one, he created a story and says, look, if you wanted to find the Eiffel Tower in a human body and you had enough time and skill, you could probably find the Eiffel Tower, but all you have to do is carve away everything that doesn't look like the Eiffel Tower, right? So I don't know how useful finding the Eiffel Tower in the body is, but the story can be particularly useful, right? Because it talks about the connection between what's happening in the sole of your foot, the domes of your diaphragm. It's not so much about like as if the story is correct or not, but it's the question is it useful? So we want to look at the body in ways that's useful as a yoga teacher. Does it have a purpose? Does it enliven our experience of being alive and walking around in this body? There's so many stories that we can tell by the different ways that we look at the body. We talked about the skin, for instance. You know, like I think about our skin. What if it's not the thing that's in the way and you throw it in the bucket? What if that's the thing you really want to study? What if you want to see the skin as a whole layer? Well, Gil asked that question in the lab too and decided to do it. So the question was, can we take the skin off all in one piece? So he tried that. And in that cadaver footage, you've already, I think that it's out there. I'm not sure if it's one you have to pay for, if it's a free one on YouTube. It's a little intense to watch and it may not be what you want to look at. Just giving you a heads up there, you know, but Gil took off the entire surface of a person's body. So you could see it as a layer and you could check how heavy is it? Where is it thick? Where is it thin? Where is it rough? Where is it smooth? And where, for example, doesn't it come off in a layer? Like the area around the perineum, just in front of the anus, it's kind of folded in onto itself and anchored in such an intense way that you can't just peel it away like the rest of the body. So you learn a lot about the skin by treating it as a layer. But again, this is a story told with a sharp instrument, a scalpel, right? Does it transmit light? That's it. It's a good question. All you have to do is put a bright light source behind it to find out, and indeed it does. So what does the story tell about your skin when you're out in the sun? The fact that the sunlight and all the radiation is penetrating the skin and getting into the layers beneath. The layer beneath the skin is a fat layer that's embedded in the superficial fascia, right? And it stores energy as an important immune functions, right? So it tells us a different story about why it's important to be in the sunlight from time to time. We can learn about ourselves by holding a sharp instruments in all sorts of different ways. What about the fat layer, right? On the same cadaver that Gil was working on, he decided to see if they could take off the superficial fascia with the fat layer. Can we do that? Turns out, yes, you can. And this is the same cadaver. It's the same deep fascia. You have to go through this to get to the muscle. We haven't seen any muscle yet, really. So it's just skin and fascia and fat, right? But here, as if taken off a wetsuit, you can see the superficial fascia layer with the fat embedded in it and the breast just laying next to her on the table. It's a very compelling story when we think about how we tend to almost demonize that layer in our society. We want to get rid of it. It's a warm, comfy wetsuit layer that's enveloping us and has such important functions. We need to honor it so that these examples of anatomy are as a story, right? Just as a vast number of nearly infinite potential details of anatomy and so many stories that can be told by the different ways that we look at our body and examine it. We want to think like how we choose the stories that we tell that are most useful for us as yoga people and people who want to teach yoga to other people. So this is where we come back to the fundamental concepts and the lenses that we're looking for, right? The right concept can function as a lens to show which details are important and which details are less important. And these lenses are like stitra, sukha, right? Those opposites, prana and apana, sukha and dukkha, and some of the key sutras that we find in the yoga teachings, which I believe are true and compelling, not because they're ancient, not because they're transmitted from some mystical or other dimension, but because they relate to fundamental biological principles that bring us back into ourselves. And we can verify the truth of these principles by going into ourselves in an embodied way. So this is, again, another way of that anatomy is a story about our human beingness, right? So we want to empower ourselves and to give us enough confidence and curiosity to learn our stories, to start telling your story when you're talking about anatomy in the classroom and coming back to the stories of people like Gil Hedley or Leslie Kaminoff, right? When we spend time with their ideas and the way that they explore things, it helps us to turn around and explore our own human beingness, right? And so the books, we just talked about that, like the books and the art is one way of representing the average humanity, and that the cadaver is a way of representing a specific, but we're individuals, right? This book is me, it's you, right? Being able to turn the sharp instrument of our consciousness, our attention into it and read this book. That is a big part of what our study is about. That's the most compelling story of all of this, right? It's telling the story of our book. What's going on with our book? How is this relevant to me? It's part of what will hold our attention, no matter how complex the literature or simplified the way of learning it. It's far more interesting as we can relate it to ourselves. And when we're teaching, if we can relate it to the individuals who are in our classes, right? So we want them to understand anatomy as it relates to their own body. And we're educating them and teaching them the names of muscles or bones, or calling something by the way that it's done, you know, like this is flexion or extension. It's an educational process so that the people in our classes, like think about some of your favorite yoga classes. What have you learned about yourself during that class? Can you think of moments when you've been in a class and like the light goes on, or an aha moment comes up, or there's something you figure out and learn about yourself because the way the teacher chose to describe it, or the way she shared about her experience helped you to relate to and understand better what was going on. Can you think of situations like that? Yes? No? Maybe?
I know I've had them. I just can't remember any specifically right now.
Mm-hmm. Is it part of what brings you back to yoga?
Yeah, definitely.
For me, I'm sure. I can remember being in my first class with Susie Diaz, a yoga teacher in Toronto, wonderful human, and a colleague of mine. And I went to one of her yoga classes, and I can remember my first time doing those Feldenkrais shoulder circles when we're laying on the floor and doing the shoulder circles. She was talking about, you know, alignment of the shoulders and somatics and this, that, and the other thing. And I remember just being so viscerally aware of how much tension I was holding in my shoulders. And I believe that that moment was a big part of what made me decide that I needed to practice yoga every day and that I wanted to be a yoga teacher. I'm like, this is the way my body's meant to move. And the way she was able to describe the movement and or invite me to explore movement and anatomy and what was going on with my muscles, my bones, my joints, my alignment, took me into a place where I felt like I was more in contact with my own felt senses, my own awareness of what was going on in my physical body than any other teacher that I'd had for yoga at that point. And it motivated me to come back to her classes and do some training with her and then go on to do other training. And my hope is that's part of why we're all here together, is to learn about how the body works so that we can better understand ourselves and our own experience, right? And so sometimes we approach from one angle, and sometimes we're looking at the forest. The language I'm talking about is looking at the big picture. And then sometimes we have to move in and look at the trees and the forest, right? So the overarching concepts of anatomy and the ways that we use this course is to understand, you know, the bigger picture that's going on. And then we have to look down and more detailed. I like to think of the value of not just looking at the trees, but at the wing, on the bug, on the leaf, on the branch, on the tree. Looking at these tiny details can help to give us some understanding of the fundamental concepts about how cells, tissues, and organs come together and underlie a lot of the things that we hear about bones, muscles, and joints. So as we move forward here, we're going to look at three kinds of tissue: the connective tissues, the bones, and the muscles. And when you're doing your presentations on them, they'll be more about the system itself and what's involved in the system. I'm going to kind of tell a story about anatomy. So all of our tissues and all of our body systems are involved in movement. But these three tissues are the ones that we hear about the most, and the most is said about them in a movement class, right? So we start with a detailed look at the physiology, the cells, and the environment that they create, what you might learn in a biology class about the cell. Then we're going to move through a small movement experience again. We give you a chance to feel it in your body. And then remember, there's no right way to feel it, no right experience to have. We're just asking questions about how we feel. And we might want to keep a notebook handy for this and your yoga mat or practice area. So if you've moved yourself somewhere where you're just sitting, you don't have your mat, you want to get your notebook and a pen and make sure your mat's nearby if you want to use your mat, or just as long as you have space to move in a few minutes, right? So we'll start with connective tissue. And as we go into looking at the physiology of the tissues and how they work, we'll look at two things. And all of the systems, we're going to look back at the extracellular matrix, what that is, and then the cells that make up the tissue. So extracellular matrix is all of the stuff outside of the cells. Extracellular means outside the cell. So the things that are in the environment around the cells that the cells engage with to get what they need, to let go of what they don't need, right? So everything that's around the cell is either coming into the cell or leaving the cell. And the things that cells are made of in themselves and extrude, so they are all of that stuff is extracellular matrix. So when we look at connective tissues, which is both a tissue and a whole system, the extracellular matrix is called the ground substance. You don't have to memorize this stuff. You can, go back and look at it, right? So the ground substance is a fluid gel-like stuff. It's kind of gel-like. It has the property of getting more fluid under pressure or heat, which, as a word, the word for that quality, you ready for this, is thixotropic. Thixotropic. Thixotropic, which is it's a great word. It's kind of a cool word. And I can say it. I can't say all the Latin words, right? It means that it gets less viscous. So viscous is thick. Less viscous means it's more fluid. There's more of a gel-like consistency to it. Less thick, less sticky, more runny when there's pressure or friction or heat. Ketchup is also a thixotropic structure, right? So or substance, right? It's not so much a structure, but a substance. So when you shake ketchup up, it gets runnier. The ground substance then, the stuff outside the cells in the connective tissue, is thixotropic. When there's pressure, so this is what I'm talking about. Oftentimes when I say all of the somatic warming up, the somatic warming up is applying pressure and movement, right, to create a thixotropic, to create more fluidity and looseness in that extracellular matrix of material, right? Makes sense? So the most common one in connective tissue is collagen. We also have something called reticulin and elastin. There are tons of other things that get included in the extracellular matrix as well. So this is not an exclusive list that I'm not trying to be as detailed here, but create a picture, right? This is the high points in a story on the map. Collagen fibers are the most common fibers in the body. They're not cells. They are things made by cells. They are kind of protein molecule. So what collagen fibers have the ability to do is resist tension. So if you pull on a collagen fiber, it doesn't stretch. It doesn't get longer. Just like a yoga strap, right? So you pull on it, it stays the same length. You pull on it and it resists being pulled apart. It's not elastic. Elastin fibers are elastic. In some extracellular matrix, some connective tissues, it has a lot of elastin in it. But all connective tissue has collagen fibers in. So some have elastin, all have collagen fibers. Right? So there's a sense of stability to it, right? The cells then in connective tissues are, and there are also many different kinds of lists of these as well. So this is just one map that we can look at. There are fibroblasts, fibrocytes, and myofibroblasts, right? This is a moment now to point out research and new information. As this is not a fixed body of knowledge, you guys know that. So some of the more recent, in the connective field in particular, there's constantly new information coming out. So people are researching this all the time. So if you go and research this, you might not find everywhere people talking about myofibroblasts, or they might have a slightly different name. So if you look at older literature, you might not see as much about it. Newer literature, you will see a lot about myofibroblasts, right? And sometimes before they had different names on it. So as new information comes out, things get different names, and there isn't necessarily consensus on what to call things yet, but cells that then are in the extracellular matrix and create the extracellular matrix are fibroblasts. These are the most common one. Fibroblasts, what they do is make ground substance, and they make collagen fibers, reticulin fibers, and elastin fibers. So fibroblasts are generating the extracellular matrix, fibrocytes. One of the jobs that they do, and they probably do other things that we don't even know about yet, but one of the things that fibrocytes do is just maintain. And, you know, like not just maintain, but they maintain, they track, they pay attention to what's going on, and they respond to stresses in the tissue. A stress in the tissue, in this case, is not a bad thing. But if there's a pulling or pressure, then along with the ground substance changing, then there's tension on connective tissue, and the fibrocytes respond. One of the things they do is consolidate, right? So they come together. They secrete a molecule that will bind collagen fibers together, and they make it stronger. So the fibroblasts respond to tension. So whatever you're pulling on, it starts to get stronger by creating more fibers. The fibrocytes and the fibroblasts together, they do a kind of organizing thing. It's very cool. Again, you have to geek out a little bit to really get this, that when there's tension in the tissue, they organize the fibers of the collagen so that the fibers and the tissue organize along the line of pull. So if I'm pulling this way, right, they start lining up and pulling that way and getting stronger. So that when there's a pull on the tissue over time, gradually the fibers and that ground substance, they'll all orientate themselves to resist the pull. So if the pull is going, if this strap were a collagen fiber, like, so if we've got a strap and it's a collagen fiber and we pull on it, the pull is going the way on the tissue. Gradually the strap will orientate itself so that it resists the pull the way you're pulling, right? The kind of pull that creates tension that would reorganize or consolidate the fibers might be something like a habitual movement pattern, or sitting in the same kind of position, or standing, or hanging out in the same shape where, say, the pull of gravity makes the connective tissues always have to resist me falling over. So muscles participating in that, but not like muscles do participate in that, but connective tissue does too. So our connective tissue is constantly responding to the positions we find ourselves in and the movements we're doing. And the myofibroblasts also respond. They're like little muscle fibers, like they're little tiny fibers in the collagen, right? Smooth muscle fibers that become the fibroblast. Not the other one was a fibrocyte. This is a fibroblast. And they respond to things in the environment, in the extracellular matrix, to signal molecules that come from the bloodstream and other fluids in the body. Things like hormones that affect the tone of the connective tissue. So the cells respond to signals in the body by proliferating the fibers, right? By consolidating and organizing, which makes the connective tissue, which is all over the body. And we're going to talk about in a minute, bone as a kind of connective tissue, right? So the more pull and push and stress on it, the stronger that connective tissue. Our tendons, our ligaments, there's sheets of connective tissue around the tendons, around the ligaments, around the muscles, around nerves, around blood vessels, around our organs, around our cavities. There is all this connective tissue. And these are the sheets of connective tissue creating relationship, maintain containment, and responding to the forces of our body, right? Okay, that's a lot of information, but it makes sense, right? So the cells are producing things that move out into that extracellular matrix, which is part of what makes the connective tissues that surround everything in our body, there is connective tissue. And in that connective tissue gets stronger by the more force and tension and pull that's applied to it. And of course, like everything, we can have negative forces that are causing too much stress. We can have good amount of force that's causing us to get the connective tissue to get stronger and to become more functional. And we can have stressors. So we've got the two ends of the spectrum, right? And like we described elite athletes earlier, but having to go on that line between being an Olympian and being injured, it's the same line for us working on our everyday bodies. We want to stress our bodies to the point where we're stronger, fitter, and increase our bioavailable lifespan, but not to the point where we injure ourselves and we damage connective tissues and we damage muscles or bones, right? Alrighty, so let's stand up and give the body a shakeout. Let's do a little bit of exploration of this concept in an embodied way, right? So we stand up, take a few steps around, give your body a good shakeout. And then just stop anywhere so that you can hear me comfortably, and just stop where you are and see if you can stand without doing too much fixing or readjusting or anything. Just stand wherever you land. So wherever you land on your 2 feet, you have your eyes open or closed. You don't have to look at me, just listen to the voice. But turn the attention inward now. Just notice where your body is. See what you notice about your connective tissue. Start to move inward. Maybe you can feel your breath and how the breath is moving. Notice how with the apparatus of the breath, is there any sense of pulling on the body? Notice any other places where you're aware of your connective tissues. One of the things that connective tissue responds to is pull, to tension. Connective tissue is so many different things in our body. It's our tendons, it's our ligaments, it's the general web of connective tissues between different layers of the body. It's part of the skin, our bones. We'll leave that for later, but right now, just get a sense in your body. Do you feel the connections between things? Where do you feel any sense of pulling? Are there any places where you don't feel tension or pulling, but you might also feel a sense of it being connected to other systems, other sensations? As you continue to stand, notice if different things start to come up. Just keep scanning the body, bringing attention to any sensations where you're aware of the connective tissue. The movement of the breath. Notice any sense of muscles firing up just to stand still. Can you feel your heartbeat? Can you notice your joints? Let the other body systems, the other tissues talk to you. But keep inviting attention back to what you imagine your connective tissue might feel like in this moment. When you feel ready now, bring your arms out to the side and slowly up overhead, feeling them moving, and then let them slowly come back down by the sides. Nice and slow. Let the arms go up and down a few times. You can do it as quickly or as slowly as you like. In doing this movement then, notice where you feel your connective tissues. Where might you feel connective tissue if those tissues were talking to you? Where would the voice be coming from? Other things may come into our awareness. We might be used to paying attention to a different kind of tissue or body system. Right now, focus on the sensations that you feel are related to your connective tissues. And how does the experience change when we're thinking about our connective tissue? The next time the arms come up, let's pause with the arms overhead. Unless you have unmedicated high blood pressure or you're pregnant, and in which case you could pause with them out wide. On the next breath, let them come down and pause with the arms by the side. Any speed that you want. Pausing and feeling. And now begin to move the arms up and down again and entertain the idea of initiating the movement from the connective tissues. Does it change the experience to start from a different state of consciousness, a different awareness? The next time we bring our arms back down by the sides, let's leave them there by the side and just stand tall. See what you notice in relative stillness on the outside of the body. And if you have a pad of paper and a pen close by, or if you'd rather, you can type on your computer. Come on out of the experience and take a few minutes to write down what that experience was like. What type of adjectives might come up about your experience of connective tissue? Give you a few minutes now to just write about that experience. How it was the same or different. Were you able to sense your connective tissue? How would you describe the sensations? Smooth, even, tense, relaxed, heavy, dark, light, blue, green. Use whatever adjectives make sense to you. All right. And you feel like you've written what you need to write about that. Let's take a moment to check in and let's talk about how did it feel to move from a place of awareness of the connective tissues in the body. Talk to me.
I think it was, for me, it was very subtle. It wasn't, I didn't feel a lot. I kind of felt it in the spots that I normally kind of have a little bit of pain. So shoulder a little bit, arch of my foot, a little bit in lower back where I don't usually have a lot of pain, but I moved something yesterday. I probably shouldn't have. So it was, it was very subtle, but it was just like almost like a slight stretching. It wasn't a pain, almost like just a little bit of pressure. And then when we did the arms and concentrated on the connective tissues, it was almost like it was smoother and less effort was needed. I'm sure some of that might have been psychological, but
yeah, that's cool. Awesome. Thank you for telling us. Other observations? How did it feel? What did you notice?
I can go next.
Okay.
So I felt open, warm, tall, light, relaxed, energized. And then when keeping at the end arms down, I felt heavy in comparison of arms up and grounded. And the last adjective came to my mind. It was positive. I liked Casey's intention for today, being positive. It just struck me, and we tend to get so negative, like humans. And so it's important to be positive, and we can train our minds to be more positive and notice good things that are happening for us. So I really like that word, Casey, being positive. Yes.
Thank you. Yeah, great adjectives. I can relate to all of that. Thank you. Anyone else? How did it feel? What came up for you? How would you describe?
I can go next. In the beginning, I felt like some kind of strong tingling in my hands and the forearms, which is interesting. And so when we were visualizing pulling, I was kind of focusing on my hands and also my thighs and my stomach. And then when we were doing the arms up and down by visualizing connective tissues, I felt like what did I write? I felt like it felt more whole body and connected, as opposed to like when we're in a pose, we're imagining the joints and the muscles that we're using to like create the movement. It felt like the whole of my like side body and upper back body and arms were engaged in making the movement, as opposed to just the shoulders and the biceps and whatnot. And then at the end, I felt also very heavy because of the way of thinking through that process.
Awesome, awesome ways to describe it. Nice. And Casey?
So I wrote tense, red/veiny, long, tight, compressed, and warm.
Interesting. I have to pause to feel all of those. Yeah. Interesting. Veiny. That's an interesting feeling. Veiny.
That's kind of what I like,
Yeah.
half what I feel, but also what I'm visualizing when I'm thinking of my connective tissue.
Beautiful, beautiful, and really great. So now the next step is to think about the next time you're describing or teaching a yoga asana, how could you use the story of connective tissue to guide someone into a simple pose? All right, so maybe just write down how you would, from Tadasana into Warrior One, how could you use connective tissue to describe how to get into the pose and invite exploration of the posture? Want to write that out? Take a moment with that. I'll give you about 5 minutes. All right. You can keep writing. If anyone feels like they're done, and you could start by sharing the description with us. I'm going to give you another minute to write. I'm going to run to the washroom. I'll be right back. All right, how we doing? Anybody feel ready to share? Do I need to voluntold someone? Sneha, you're smiling. You ready?
Damn it. I wrote as you're getting into Shavasana and relaxing into it, if this is kind of towards the end of a practice, noticing which body parts are starting to feel heavier and tend to settle easily into the mat, and kind of noticing what parts of the ground they are contacting with, and what parts are kind of making physical contact with the ground, and then noticing which parts of the body may still be experiencing any kind of vibrations or feelings of movement or tension, and trying to focus on relaxing those connective tissues and muscles, and bringing them to kind of the level of the rest of the body to relax into the mat.
Awesome. Awesome. Really good awareness. Yeah, good use. That's a great way to use that. I can almost feel it while you're saying it. Awesome. Anyone else? Feel ready? Elvira?
Are we supposed to be doing from Tadasana the Warrior One pose?
Yeah, sure. And all is accepted and loved.
Okay, so standing with your feet flat under your hips, and feeling your feet rooted into the ground like a mountain. You can close your eyes and take 5 long, deep breaths, fully feeling grounded into the surface, and then exhale and step with left foot back. Extend your left foot and fully empty your lungs, and raise your arms all the way up, reaching up to the sky, looking up at your hands, and lowering, relaxing your shoulders down and back.
Awesome. Awesome. So now what if we added into that, when you step back with your right foot and you move down into the soles of the feet the same way that you were in Tadasana, I feel a sense of connected as you start to inhale and raise your arms up. Where do you feel the movement initiating from? Could be a question. So you give a direction and then invite them to explore what it is that they are feeling. So where do you feel, like when you start to, even just seated, start to raise your arms overhead from seated. So as you raise your arms overhead from seated, where do you feel like you're initiating the movement from? And then wherever it is you're initiating the movement from, now imagine all your connective tissue, the tissue around your muscles and joints and tendons. And then as they come back down through space, imagine that tissue is initiating the movement coming down. So we can bring in that exploration, right, so that you're inviting people to feel the movement in a slightly different way than just the mechanical, traditional anatomical way or colloquial way, but inviting them to notice if there are any other sensations that they can move into the brain with a different approach, right? I like how Tina explained she could feel, or was it Casey? I can't remember who said it, but someone said that they could feel like their side body and their back being involved in the movement and not just the arm or the joint or the muscle, right? Awesome. Thank you. Anybody else want to share with us what they wrote?
Yeah, I will. Mine's kind of short and sweet. So standing in Tadasana, elongating your spine, stepping back with your right foot, noticing any feelings of warmth, Bend your left knee over your left ankle, raising your arms in front of your body, feeling the length, and then letting them rise above your head, lifting through your chest.
Awesome. Awesome. And I would say the same thing. Just again, you've given really great instructions, awesome anatomical, awesome colloquial language of movement, and I can completely visualize and know where I'm supposed to be. Then what about inviting me to explore where I am? Hold it. You want me to hold it for 5 breaths. Now, as you hold it, then find some language that starts to connect them with their connective tissue. Like, how can I talk about, or what question could I ask? Like, where do you feel heavy? Where do you feel light? What do you feel, where do you feel like this movement is originating from? What's allowing you to stand here and hold this? Are other muscles starting to get engaged the longer you're here? Can you feel the sense of what's enveloping the muscles? Is there tension there, or is there a fluidity, right? Those kind of language like we used in this exploration of standing and exploring our connective tissue, bringing that into the asana. Awesome. Thank you. All right, Tina, what did you write for this one?
Really didn't know exactly how to put them together, so I just
Perfect.
yeah, very visual. So I have a hard time writing and reading. I kind of need to do it a little bit. So I just did stand tall in Uttanasana, feet grounded into the mat, crown to the ceiling, step your right foot back, and bend your left knee. Get steady in position. And when you're ready, raise your arms to the sky and look up. How did that feel when you raised your arms? Lower your arms down slowly and see how that feels.
Awesome. Love that. And I'm going to come back to one cue you gave that was beautiful, right? Stepping back. I think you had, was it in mountain or stepping back? You had us reaching up to the crown of our head, right? Then you reached up to the crown of the head. Then here's another really cool connective tissue cue. Remember, pressure and tension. Feel gravity. Feel gravity moving down. Where do you feel gravity? Where do you feel gravity? And what's it do? Where are the pulling sensations of gravity? Even as you draw up through your core, what is gravity doing? Can you feel gravity on the skin of your face? Can you feel gravity on your chest in any way? I think those are some ways to get even more into the connective tissues of the movement, right? And feel what's happening on this in the extracellular matrix. Don't you love that expression? I mean, am I just a bit of a geek? I mean, I'm a bit of a yoga geek, but extracellular matrix, that's the stuff around the cells. Is that Dad in the background there? Who's in the background? I saw someone peeking their head in. You say hi for us. Is he learning about yoga too? Or is he's like laughing at us because we're talking about extracellular matrices? I don't know. That's okay. Tell me,
Sorry, he was noticing my mom's background was gone.
Oh.
Because it was the beach before.
That's awesome.
Yeah,
we love
I don't know.
That's the nice part about virtual yoga. Family wanders in and out of the background. It's fabulous. We haven't seen your family yet, Elvira. Maybe one day you're going to turn the camera around so we can see them too, when they feel comfortable with it. All righty. Good job, guys. I mean, so now you like just think about exploring our poses and bringing that awareness to it. So one more we're going to jam in before we take our next break. So we're going to talk a little bit about the next piece of, again, the same connective tissues. We said the bones were a type of connective tissue, right? When we think about bones, tendons, ligaments, all are connective tissue. Ligaments are the connective tissue that connects bones to bones. Tendons are the connective tissue that connects muscles to bones. Bone itself has all this extracellular matrix and cell kinds of composition, same as we talked about before. And we look at what it is in bones, though, it's a little differently organized or named anyway. So the extracellular matrix in bones has, among other things, collagen fibers. We talked about collagen fibers, and they have crystallized cell salts on those collagen fibers. Crystallized minerals that attach to them. So the calcium, the magnesium, those things we hear about we need to make our bones strong. What they do is they attach to the collagen fibers, and they make the collagen fibers transformed from being able to resist tension. So if let me grab my strap, right? So if my strap is a collagen fiber and we say, it resists tension, but it doesn't resist compression very well, right? It folds up on it. So I can pull on it and it won't let me tear it, but if I push on it, bloop, it collapses, right? Whereas a bone then is unique in our connective tissue in its ability to resist compression. So the crystallized minerals that wrap around the collagen fibers then make the bones able to resist being crushed. What that means then is if we can transfer weight so that if I put some force on one end of the structure, it's transmitted to the other end without giving way or folding up or crumpling or bending. So that's the firmness of the bone that develops from the attachment of those salt crystals to the collagen fibers. The cells then that maintain that are called osteoblasts, osteoclast, and osteocytes. Again, don't worry about memorizing it. You can always look it up again if you're interested. Now, any of the stories that we tell, we might read up to 4 or 5 different kinds of bone cells, right? You might read that there are 2. I'm going to suggest that there are at least 3, and that what osteoblasts do is that they build bone. What osteoclasts do is that they break down bone. And what osteocytes do is they maintain the bone. So we have something that creates, something that destroys, and something that maintains. And we look at how all of that gets organized into different layers. Then we can see that this detailed picture, which you can look at videos and it'll show you all of those parts of it. And I think we have some of those in the course pack, so you can take a look at that when it's convenient for you. And it shows on the outside, the outermost layer, it's called the periosternum. So this layer on the outside of the bone, so the very outer layer of the bone, it has little fibers that connect it into the thicker, denser part. And all of the blood vessels that go through this thicker part, which is called the compact bone, it's all very well organized. The collagen fibers with their mineral salts around them are organized into columns. And the columns, like in the connective tissue, are organized now in response to pressure. So we can see, for example, in a longer bone, so we got a longer bone, that the compact bone, which is the dense part, right? The fibers of this are going to be organized along the lines of force. When we get to either end of the bone, we can see that the fibers are going many different directions because there are many different forces coming in. So the collagen fibers in the compact bone are organized in response to the force traveling through it. When we get into the deeper part of the bone, then we see what's called the spongy bone, like in through the trabecular bone, and inside of those spaces. And then there's very center of the bone, there might be a cavity which has bone marrow. And that marrow, so if you're a meat eater, you probably know all about bone marrow. It's part of what we make meat broths with. And the marrow is where we make our red blood cells in our bones. So all of our bones are permeated by blood vessels communicating from the marrow with the rest of the body. So the bone as a whole is a part of our structural system and an essential part of our circulatory system. And you know what? We very rarely talk about the bones being part of our circulatory system. We describe how we breathe, we describe how the heart or the lungs and the transfer of gases and that, but ultimately we can't breathe without bones. Right? The bones are making the red blood cells. The red blood cells carry oxygen and carbon dioxide away, right? And so we have to think about bones as part of our circulatory system. All right, so let's stand up and have an experience of bones again. So let's find your way to standing. If you need a little sip of water or something, give your body a shake out again. Give your hips a shake, give your feet a shake. All right, and we'll take a few steps forward and back, maybe go around in a circle a couple of times like a puppy, and find your spot. Find a spot where you can stand comfortably. That's it. You find yourself into a spot where you can stand up without a lot of fussing. Just let your feet get grounded. See where your feet land. Then let your attention begin to turn inward once again. Find a sense of self. And now we're going to bring our attention to our bones, which are a kind of connective tissue that have developed to resist compression. Where do you feel weight? Where do you feel pressure? Let's invite that question into our bones. In our bones, where do we feel weight? Where do we feel pressure? So we can certainly feel weight or pressure in other tissues in the body, but can we use the question of weight traveling through the bones to bring attention to our skeleton? Notice if your attention's drawn to your muscles. It may be that our attention is drawn to our connective tissue or to something else altogether. We have all kinds of sensations all the time in our bodies, but tune in now to an awareness of the bones. What kind of experience arises as you begin to notice your bones? Sometimes the bones are quiet. Sometimes other things talk to us more loudly or are more noticeable. How is it to settle into a sense of how the weight travels through the skeleton? Notice if you feel any sense of ease or the sense of weight. Are you standing up as much as you usually do, or as tall, or are you leaning forward or back or to one side? Notice any ideas are being cultivated or sensations that are arising from exploring the weight of the bones. See if you can not fall down, but not pull up either. How do you stand in neutral? How little effort can you exert to feel the weight of your head travel through your spine? To feel the weight of the spine travel through the legs. To feel the weight of the shoulders, the bones, the arms, the hands. And then how would it be from the bones of your fingers? Imagine using the bones of your fingers to lift your arms up now. Can you do this movement of bringing the arms up, out and up, keeping your attention on your bones? Can you lift and lower at any speed you like? How is it to initiate this movement from an awareness of the bones? Shift to the forearm bones. Arms up and down with the forearm bones. Ulnar, the radial. Is it a different experience than initiating from connective tissue? Or does it feel the same? Certainly to lift our arms up, we need other tissues, but we're trying to focus in on the bones. I know we need muscles and connective tissues, we need blood, we need all kinds of things to lift our arms, but if we initiate the movement from an awareness of our bones, does your experience change in any way? Up and down. Feel free to pause with the arms overhead or down by your sides and experience and feel the pull of gravity. Feel the presence of our bones. And let the arms come back down by the sides. Pause, feeling gravity, feeling the bones, feeling the weight of the skeleton. And then when you're ready, head back to your writing materials and tell us a story about how it feels to move from the bones. What kind of adjectives might come up about your experience of the bones as connective tissue? All right. And so we're going to let's take a moment now to connect as quickly. So let's share your top 3 words that would describe how it was different and or the sensations you had most predominantly with bones and the same movement.
For me, it was heavier, thinking about the bones as opposed to the muscles, less fluid in the movements, and more pulling. If that makes any kind of sense.
Mm-hmm. Awesome. Thank you. Anyone else?
So I wrote heavy as well, crunchy and strong.
Good words. Jim, anyone else?
I wrote inertia, like solid mass and gravity.
Right. Interesting. Awesome. Elvira?
So grounded, heavy. Also, I noticed the heaviness, and also it felt uneven. One leg in comparison with the other one And the same with arms, 2 arm bones. Like these ones are the left one is lighter than the right one. And I don't know, I'm right-handed. Maybe that was the difference. And then when I went up, it felt less grounded, but lighter. And when the arms are down, more grounded and heavier.
Okay. So it's a good thing as well, thank you, to think about how can I talk about bones as connective tissue in movement stories? How can what kind of questions and or invitations to explore space can I suggest? So just maybe adding in some notes to your exploration of a posture that you used from the last one. What other words could I use to invite awareness of the bones, of gravity, of the weight on the skeleton, lightness or heaviness, grounded or inertia, all of those kind of things. And Sneha, I think I have a suggestion for you. This might be just a good exploration of think about when you're designing space, how can you use this language of connectivity, of connective tissue? How do the structures become stronger through the force and or respond to gravity? How do they respond to the use of those structures? I think this would be a good just a journaling point for you today. If before the end of the day, while it's really fresh in your mind, I would think about it in terms of other structures and how you can use this language to explore the idea of the interconnectivity of structures and their uses and or how we feel in them or how they're felt or how we relate to them. Just play with those ideas. Something might arise. Alrighty. So I think we have time to very quickly, again, because we're kind of getting used to this process, go through muscles really quickly. So we're going to talk about the same things. The organization of muscles, and we'll just take a slightly different look than, again, what the person, whoever's going to do muscles in the anatomy part. This is just about talking about the extracellular matrix and looking at the layers of connective tissue that wrap around the muscle cells. So a muscle cell is called a myocyte or a muscle fiber, right? And it can be confusing because we talk about collagen fibers and they're not cells, but muscle fibers are muscle cells. So it's a little confusing. They're called fibers because they're organized along in long strands. So a muscle cell is many, many, many premature cells that have come together so that they have many nucleuses in them, and they are nuclei, I think it's nuclei, in them, so they organize themselves into long strings. And they bundle together, and they get bundled together and wrapped up with extracellular matrix, in this case with connective tissue. So at their deepest layer, they're wrapped in something called endomysium. And then those bundles will wrap together in paramysium, and then those bundles wrap together in epimysium. So the bundles will wrap together to make a tendon, which ends up looking something like it's like the piece that connects. It looks like connective to. It looks like a collagen-y, more. It's like the strap, it doesn't resist, but the muscle that it attaches to has a more elastin in it, right? So the bundles wrap together to make a tendon, which ends up looking like, again, the attachment end. If the cells are red, say, and the connective tissue around them is green, and the muscle cell has many little nuclei in it, and these fibers inside the cells, and they all get bundled together. So these muscle cells all wrapped up, and when they get bundled together and wrapped in connective tissue, and all the connective tissue is in between them, so connective tissue does this separating and connecting action. So it wraps muscle cells together into something called fascicles. and a bundle of muscle cells. Then all of those fascicles are going to get bundled together so that there's hundreds and hundreds of them. This is not nearly as many as there would be, say, in, so just think of a small muscle. And they get bundled together by the pericynium, and the whole thing gets wrapped in epimysium, the outermost layer wrapped up into this connective tissue and the bundles of their blood vessels and nerves. So to actually make a muscle, we think of as a functional muscle. It's an organ in the sense that it has muscle fibers in it, connective tissue in it, blood vessels in it, and it has nerves in it. So when we take that and we take the connective tissue and connect it to the bone, then we get something that, you know, looks like your bicep, right? So your bicep, bi means two. So there's two sets of bundles, right? So there's two sets of bundles that attach to the tendon, and the tendon attaches to the bone, right? And the muscle itself is attached to the bone because the blood vessels are going in through the muscle and into the bone, right? So when we've got all these wrapped up bundles where the muscle cells stop, the connective tissues fibers come together to make the tendon, which connects to the perosternum and the bone, and the outermost layer of all the connective tissue that wraps around the bone. So then there's some more fascia, there's more connective tissue that wraps around the two pieces of that muscle. The muscle cells are unique in their ability to respond to the signals from the nervous system and contract and slide and to become shorter or release and become longer. When they do that, when they contract and slide shorter, they pull on the tendon, right? So they're pulling on the tendon, which pulls on the bone, right? And in that way, the muscle cells are able to create movement, which is their role that they play in the body. So most of our muscles are going to create movement in some form or another, right? So we've got the connective tissue story is that all of the muscles are wrapped in connective tissue, this extracellular matrix of material that is elastin. Mostly there's collagen in it, which is inelastic, but there's elastin, you know, the fibroblasts that are elastic, there's elastin in there, and that is able to stretch and release. So if we go past our current level of flexibility, what happens to the muscle? What do you think happens? Because it's elastic in nature, but if we go past it, the ability for the muscle to extend, we can tear the muscle. And if we tear the muscle, if we go past the muscle's ability to extend, we can go into and tear the tendon. Sometimes when we load the muscle and the joint with excessive weight, with more weight than it's able to manage, this is how muscle tears and tendon and ligamental tears happen, as we overload it or ask the muscle to do more than it's capable of at that time. But if we have a progressive loading of those muscles, they get stronger and stronger. If you remember what happens, the more we pull on those connective tissues, they become stronger, right? And they start to develop striations in the direction of the pull, right? So if I'm doing bicep curls, do them with my water glass, right? If I'm doing bicep curls with my water glass, right? So the movement, the tension is in the longitudinal way across the bicep muscles. And it's one of the reasons in the gym, right? You'll see people doing lots of different movements. So they're getting fibers to build up in longitudinal ways, in latitudinal ways, and diagonally by using different arm movements and extending and contracting. So the higher weight we use, movement in yoga, well, it's getting pretty windy out there. Holy smokes, right? Everything's a blowing, right? And so the more pressure that we're applying, right, the more dense that connective tissue is becoming. So it's not just those muscle fibers that are getting stronger, it's the connective tissue around the muscle fibers. The fiber is bundled, then there's bundles of fibers, and then there's bundles of fibers. And in the case of the bicep, there's two sets of bundles, right? And then there's connective tissue over all of that, and then there's fat and fascia and skin all over that, and in there is fuzz. So there's a whole bunch of things happening all at the same time. So let's come to standing one last time. And this will be our last one for this session, right? Is come into standing, give yourself a shake out one more time. You know what's coming. Walk around, find your spot, take a few steps forward, a few steps back, 1 foot in, 1 foot out. Find a place to settle where you can stand on both feet again, move down through the soles of the feet. And once again, turn the attention inward. And notice how much easier it is to turn inward as we repetitively practice this type of somatic awareness of the body. Eyes can be open or closed. And see now as you stand what information you get about your body and your bones and your connective tissue. And then see what your muscles are telling you. What's the story of my muscles today? What are the muscles telling us about movement, even though we're standing still? What are muscles telling us about moving the bones, about moving our fluids? What are our muscles telling us about the tiny little movements that we're making to keep our balance even right now? What muscles are active to just stand up against gravity? Just standing still. What are our muscles telling us about the movement of our breath and other movements in the body that are adjusting to the movement of the breath? Any of these might be familiar, they might be unfamiliar, you're just not used to paying attention to them. We all have these tissues, but which ones we pay attention to vary from day to day, person to person. So when we start to pay attention, when we listen or feel what our muscles have to say, what kind of experience arises? What do we notice about our muscles? If you're getting a lot of information about the muscles in one area, can you spread that question around? And then how do those tiny movements that may feel large on the inside, the movement of the breath, adjustment of balance, can those spread into moving your arms to bring your arms out and up to the side and overhead again? And back down at any speed you like, as many times as you like. Keep going up and down. Maybe at some point holding them up, or at some point holding them down. As you lift and lower your arms, what is your experience of your muscles? Imagine initiating the movement from the muscles. Is that different from initiating with the bones or the connective tissue? Explore all three. And on the next breath, if you haven't already, let the arms come down by the sides. Leave them there by the side and see how you experience all of the systems together. Connective tissues, bones, muscles, tendons, ligaments. And when you're ready now, take a seat and begin to write about these experiences. And what I'll do is I'm going to let you go here. We'll come back together at 3 o'clock, but write about your felt senses here. How would you describe this experience of moving from the muscles, being aware of all of the parts of this apparatus, how it's different or the same, and then think about describing yoga asana in these terms. All right, I'm going to sign out, let you play with that, take a few minutes, don't take too long on it, and then take a break. Go outside for a few minutes, get some of that fresh windy air on you, or if you've got rain, get a few raindrops on your face. It's got to be good for you. And we'll meet you back here at 3 o'clock, okay?